So today we're going to be talking about Bronsted-Lowry Acid and Bases. And so the definition of this is really centered on the transfer of a proton, which is an H+. And so an acid is a donor and a base is an acceptor of H+ or protons. So what that looks like in a reaction, you can have something like HCl, where the H is the proton donated, plus water gives us Cl minus plus H3O plus, where here is the proton that was transferred both times. So now that we have the definitions down of that, we have to also remember that after the proton transfer, the chloride is now the conjugate base. And then the H3O plus would be the conjugate acid. So anytime we have a proton transfer from an acid to a base, we will end up with a conjugate base and a conjugate acid, respectively. Now, as we might know, all reactions are really accomplished through a flow of electrons. And this type of reaction is no exception. So now we're going to look at how to draw that type of reaction and that reaction mechanism. So we have a base, which is going to be OH. Those electrons plus an acid This will yield H2O plus now what we have is these electrons moving towards this proton, and then that removes this bond, and those electrons flow back to the oxygen. So now this base becomes H2O, which is the conjugate acid, and this becomes our new conjugate base. All right, after this proton transfer. Now, let's cover a couple more examples. So, let's do, as our last one, plus yields a little bit of a bad drawing. plus, right out of room, so we're going to include that down here. Okay, so I like to label things usually as acids or bases first before doing them. So this is going to be our acid. This is our base. That means this is our conjugate acid, which I'm going to do Ca. This is our conjugate base. This would be our conjugate acid. So now we're going to look at the flow of electrons. Now we have to remember that this CH has 3 protons. This carbon has no protons here. This one has 1 proton. So what's going to happen is these electrons on the nitrogen are going to go to 1 hydrogen, and then these electrons from the hydrogen are going to go down to this carbon. And that's going to give us a carbon anion here and result in the proton transfer of this from here to the nitrogen. All right. That covers the basics of Bronsted-Lowry acid-base reactions. Why don't you check out the next video so we can talk about quantitative versus qualitative perspectives and pKa values. And visit our website at chemgenius.ai for some more chemistry help.